In this lesson, you will learn to calculate lateral area, total area, and volume of cylinders and cones. Now with cylinders and cones, the formulas will be the same as we learned for prisms and for pyramids. So for cylinders, the formulas will be the same as the prism formulas. So to find the lateral area of a prism was simply the perimeter of the base times the height. The total area was the lateral area plus the two bases. And the volume was the area of the base times the height. And here is exactly the same thing. The only difference is the perimeter of the base would now be the circumference, so circumference times height. And then the area of the base is the area of a circle, which would be pi r squared. So the area of the base would be pi times radius squared. That is the only difference in this lesson for cylinders. And so here, the lateral area would be circumference times height. Circumference, remember, is pi times diameter. So the formula would be pi times diameter times height. And so you can use that formula, or many times you'll see the diameter written as 2 radius. So what you have sometimes is 2 times the radius times the height times pi, or 2 pi r times h. So either formula is fine, but just know where it comes from. And if you know where it comes from, you don't really need to memorize the formula per se. You can simply use the formulas we already know. And then total area, we take the lateral area, plus we add in the two bases. And the area of the base is pi r squared because it's a circle. So the lateral area was 2 pi r h. And then the two bases would be 2, and then times pi r squared. And that's your formula. And then the volume formula was area of the base times the height. And the area of the base was pi times radius squared, because that is the area of a circle. So here we have pi times radius squared times height. And so that's the formulas for a cylinder. Now using this, let's say we're given the radius to be 4 and the height is 6. All I do is I plug in the numbers into my formulas. So knowing the formulas is the hard part. Once you know the formulas, just plug the numbers in. So lateral area, the radius is 4, the height is 6. So we have 2 times pi times 4 times 6, which would give me 48 pi. Total area, we take the lateral area, plus we add in the two bases. So we take 48 pi plus 2 times pi r squared. Pi r squared would be pi times 4 squared, which would be 16. And so we have 16 pi times 2 is 32 pi, plus 48 pi would give me 80 pi. And then the volume is pi times 4 squared times 6, which would give me 96 times pi. And you can calculate each of these by plugging 3.14 in for pi if you wanted. And you see the answers for lateral area, total area, and volume would be right here. Volume, by the way, would be inches cubed, not inches squared. So that was my bad. Okay, and then moving on, if you were given the volume and you're trying to find a missing value. So here we're told that r is equal to h. So the radius and the height are the same. And the question is find r. Well, if the volume is 64 pi, I can use my volume formula of pi r squared h. And because r is equal to h, I can replace h with an r. So what I have instead would be pi times radius squared times the radius. In the volume we know to be 64 pi, so I can plug that in for volume. And then I can solve this for r, because r squared times r would be r cubed. And then I can solve this by getting rid of the pi away from the r. So divide both sides by pi. And now the pi's are gone. I'm left with 64 equals r cubed. And then to get rid of the cubed, I need to do the opposite of cubing, which is cube rooting. So take the cube root of both sides, which will get that to cancel. I'm left with r equals the cube root of 64, meaning what cubed would give me 64? And that would be 4. So the radius in this case would be 4. In this example, you're given the volume and you're given the height, and the question is to use that information to find the lateral area. Well, what I can do to begin with is I can use the volume and the height to find the radius. So the volume formula is pi r squared h. I can plug in an h for 3, and the volume is 27 pi. So when I plug those in, I can then solve this for r. To do that, I divide both sides by a 3 and a pi, which would get these to cancel. And the pi's would cancel over here. 27 over 3 leaves me with 9. So I have r squared equaling 9, and so then r would be 3. So using r, I can then find the lateral area. Lateral area by definition would be 2 pi rh, or circumference times height. And so then plug in the 3 for the radius and plug in a 3 for the height. So now I have 2 pi times 3, which would give me 18 pi for the lateral area. And now dealing with cones. Cones are identical to pyramids. The only difference is the base is a circle instead of a polygon. And so here, when I find the lateral area, with a pyramid, it would be 1/2 of the perimeter of the base times the slant height. Now here, the perimeter of the base would be the circumference. So the perimeter of the base we can replace with your circumference formula, which would be pi times diameter. And if we wanted, because 1/2 of the diameter is the radius, we could think of this as radius times pi times slant height, or pi times radius times slant height. And then using this information, this picture, we have 8 for the radius, slant height is 10, so you plug those numbers in, you get 80 times pi. And then total area, you take the lateral area plus the base. Well, the area of the base is found by taking the area of the circle, which is pi r squared. So the lateral area we already found to be 80 pi. The radius is 8, so now we have pi times 8 squared, which would be 64 pi. And then add that with 80 pi to get 144 pi. And then volume is the same as with a pyramid, where you have 1/3 the area of the base times the height. Well, the area of the base we already found right here, we found that to be 64 pi. So we have 1/3 times 64 pi, multiply that by 6, which is the height, and that's going to give you your volume of 2 times 64, which is 128 pi. So notice for all of these, the formulas are the same. The only difference is the base is a circle instead of a polygon. And that concludes our lesson for today. We will see you next time.